We initiated a project to really look at what the option space was going to be to resolve this power and cooling problem that we had in a legacy data center. We had looked initially at some colo facilities, but that was kind of the traditional assumption that that would be the solution. The reality was that the cost of that for the types of workloads we were running, it wasn't so cost effective. We have moved some things to cloud, but we really still had the fundamental problem of how are we going to support much higher power and cooling densities in a data center that wasn't initially designed for that. We looked pretty broadly across the whole landscape of technologies of who's doing power and cooling, and took the time to really try to understand what was going to be possible to cost effectively deliver up to 30 kilowatts of cooling and power per cabinet, and that was quite a challenge for us. We spent roughly 12 to 18 months looking at a lot of different options and really realized that going to a pumped refrigerant solution was a lot more cost effective from an OpEx perspective than other options that we'd already been deployed. So we really started looking deeply at pumped refrigerant rear doors, active doors. And the key piece here really is that the phase change effect that happens when you're basically taking liquid refrigerant and pumping heat into it, and it expands, it flashes into a gas. That change from a liquid to a gaseous state really extracts a tremendous amount of heat energy, a lot more than water can. And also has the added benefit that there's very low pumping costs because you're circulating relatively small amounts of refrigerant as opposed to many gallons per cabinet. And so there's just across the board a number of different efficiencies that just out of the fact of having physics do the work to extract the heat. Today, it's 4 years later, almost to the day. One of the real benefits that came out of all of this was realizing the efficiencies of moving to this type of cooling. It allowed us to really make some dramatic changes to our operational costs. When we look within the data center, going to a pumped refrigerant and the way we designed this, it reduced the cost of cooling within the data center by about 90%. So instead of running off of legacy cracks, we're able to now start removing cracks. But we're also just not circulating as much water as we used to. We're able to run everything with a much smaller flow of liquid refrigerant in every cabinet. When you look at that across the entire delivery chain from the chiller plant all the way down to the servers, that represents about a 20% overall reduction in our operational expense, which is a really dramatic savings. So we've been really pleased with that. In our old data center, we were only able to deploy a single UCS chassis at the base of the cabinet, since we could only support roughly 3 kilowatts per cabinet. Those chassis can go to 4 kilowatts just for one of them. We now operate 6 of them in a single cabinet, which has allowed us to physically reduce that again. But it's also given us the ability to actually drive the individual blades much higher loads. We weren't able to really fully utilize every single component to their full capacity because we just couldn't support the thermal overrun. Now we can. We can basically use a lot more compute load out of given equipment we already had without having to curtail that. So one of the other benefits that came out of moving to a much higher power and cooling density type of solution is that it allows us to physically consolidate so much of our data center. I'd estimated probably almost 3 or 4 to 1 in terms of physically consolidation of cabinets. And when you do that, there's a lot of other tangential costs that are avoided. It's a lot less networking equipment, a lot less cabling, a lot less just cabinets and PDUs and all the components that go with that, a lot of security controls. Everything gets cheaper when we get smaller. And that we found is a really big advantage for us because as we collapse the data center, we're actually able to give floor space back, which actually is one of the most valuable commodities that we have as a corporation. So the idea of making things smaller, taller, more thermally efficient really was the thing that drove the efficiencies. On the panel today, here we are at DICE 2019 in Chicago. One of the key takeaways was really a realization that a lot of colo operators are finding that more customers are starting to bring higher compute densities to them. A lot of conversations about how colo operators are responding to that demand, but from an IT perspective, there's a lot of efficiencies in operating a much denser compute environment. It really gives us a lot of economic advantages in terms of OpEx, but also from just a straight-out acquisition perspective, we're buying less equipment, but much more powerful equipment. And I think that trend is now really becoming much more mainstream than it was perhaps 5 years ago when we started our project.